So, good morning, friends. Today, I will discuss, you can call it the application of partial fraction method, which is a method of integration for deriving a second order kinetics, or sometimes it is called the second order reactions. So therefore I have given the title, it is second order kinetics and partial fraction method. Partial fraction method is a method of integration. Sometimes it will help us to integrate a system. We have to decompose or we have to break a system into a simple system. So therefore it is called the partial fraction method. Before I start this partial fraction method and second order kinetics, I am giving a very simple numerical problem. This is actually a reaction of nitroethane and sodium hydroxide. It is just like your saponification of ester. And I have taken this numerical problem from the book of physical chemistry, Atkins, old edition, not new edition. And my question is that, of course, it is second order reactions. And we have already determined the second order rate constant, that is suppose 39.1 per mole per minute. Okay. Please see very carefully the concentration of nitroethane. I am talking about the initial concentration of nitroethane is 0.004 m. And the concentration of another reactant, sodium hydroxide, is 0.005 m. I think we have given this experiment in your practicals, but that is not the nitroethane but ester and sodium hydroxide. And I told you that please keep the concentration same. So my question is that, how long will it take to 90% nitroethane to react? So it is confirmed that it is a second order reaction, but problem arises that which formula should you use for solving this equation? Now this is a very common reaction and you are all aware of these reactions, that one ester react with sodium hydroxide, and suppose you just same thing, concentration of ester is 0.005 and concentration of sodium hydroxide is suppose 0.004. Now that is A is not equal to B and some part of sodium acetate is X and alcohol is X. And I think you are not aware of such type of a big formula. That means K2 is the second order rate constant, 1 divided by A minus B, that means the concentration of the two reactants, then T natural log B, A minus X, B minus X. So it is little bit difficult formula. But my objective is that, how do you get this formula? Because here the concentration A is different, concentration of the sodium hydroxide is different, and this Xn. So such type of cases, we use the partial fraction method to evaluate the first integer. As because you know that initial concentration of sodium hydroxide is suppose B, initial concentration of this ester is A. So after the time T, this become x. So what is the exact concentration? So that is A minus x and B minus x. Now my question is that if you want to integrate, I am not saying that integration is not possible. Integration is possible. But sometimes for mathematical convenience, there is a different types of integration. And one such type of integration method is called the partial fraction method. That means we have to divide this part. Now, I am not talking about the mathematics, that what is proper fraction, what is improper fractions. Like I am not talking about all this complicated mathematical terminology. That means sometimes what is the degree of numerator and degree of denominator. Because if it is a proper fraction, so naturally the numerator is lower degree than the denominator. But it is an improper fraction, then of course that numerator higher degree than the denominator. But we have to split it in a simple rational fraction. So that is called the partial fraction method. Suppose and very simple algebra is simple algebra. Say for example, suppose I am giving one simple problem to the student that integrate this 1 divided by 1 plus x plus 2 divided x minus 2. You can integrate it because the mathematics students can integrate it within 5 minutes. But suppose I tell you first you just decompose it into simple fractions. So I have done nothing, I have just LCM these things. 1 plus x, x minus 2, just if I want to solve it. So x minus 2 plus 2x, x minus 2. If you solve it, you will get 3x, 1 plus x, x minus 2. So that is, both are same thing. Just I divided into 2 parts. So that type of thing is called the partial fraction. Say for example, 2 by 15 can also be written as 1 by 3 minus 1 by 5. So integration is also possible, integration is also possible. But there are certain norms. So that is called the fractional quantities can be separated into simple fraction which may be integrated. That is called the partial fraction method. And what is the objective of this partial fraction method? What is the objective of this partial fraction method? First, it makes certain integrals much easier to do. I am not saying that you cannot integrate unfractional part or the fractional part. You can, but it makes, of course, integral much easier to do. And whenever you see, when I will give some example, the fraction needs to be expressed in partial fraction before integration. So sometimes you can add these things or you can subtract all these things. So let me give some example, then of course you can understand the application of partial fraction method for this second order kinetics. So let me start with these things. Again, A plus B is equal to C plus D. Very simple. And as I told you, this is A, concentration is B, A is not equal to B, and it is X, this is also X, when T is equal to 0 and when T is equal to T. So you know, and you can write it as a K, second order rate constant, you can write also even K2, no problem. So generally I can rate like that, dx and dt, k or a minus x b minus x. Just slightly. So if I just separation of the variables, you know that it is dx a minus x b minus x is equal to k dt. That's all. Very simple. So my problem is that we can 0 to x or 0 to or indefinite or definite integral. So you can use all these things. Now we will use the role of partial fractions. Partial fraction method. Now I am not saying that you cannot solve it. There are so many methods, but many times I told you that I am using the simplest method, which is easily available for all the students. Any students can understand this thing. So I can write like that. This a minus x, b minus x, have to simple algebra. So I can write like that. A x fraction plus b a minus x. So it splitted into two simple rational fractions. Then if I take the LCM, a b minus x plus b a minus x. So you see that so I can write like that, a minus x plus, oh sorry, a b minus x plus b a minus x is equal to 1. You can call it as a undetermined constant, a and b. But we need, in order to solve these things, we need the value of a and b. Which is this? It is called, sometimes it is called undetermined constant. Undetermined constant. Undetermined. Or there is another method is also, we can write like that, 1 divided by a minus x minus 1 divided by b minus x, and just cross multiplication, b minus x divided a minus x minus a minus x b minus x. That can also be possible. And if I want to solve, so 1 b minus a, like that. But this is the simplest method. So I need the value of, because it is undetermined constant, so I need the value of first a. What I do, suppose x is equal to a minus a. X is equal to a. Suppose x is equal to a. X is equal to a. So a minus a is equal to 0. B is equal to 0. So a b minus a is equal to 1. So a is equal to 1 divided by b minus a. A is equal to 1 divided by b minus a. Or you can write, if you want to write ab, so that is equal to minus a minus b. Same thing. A is equal to 1 divided by b minus a is equal to, just I change the sign, minus a by b. Very simple mathematics. Now we need the value of b. So in this case, suppose x is equal to b. X is equal to b. So b minus b, 0. 0 into 8 equal to 0. So b a minus b is equal to 1. So b is equal to 1 divided by a minus. Fine. So I am getting two values. In one case, a is equal to minus 1 by a minus b, or even you can write 1 by b minus, and b is equal to 1 divided by 1 minus. Now it can be very easily integrated. That means if just I want to use this value of, now it is in place of dx a minus x b minus x, it is actually, now it is a minus x plus b minus x. That means in place of this I can write like that. So in first case, what I do now, with the help of the partial fraction method, I have splitted this equation two parts. One is a minus x plus b divided by b minus x, and now we know the value of a and b, and you have seen that it is almost common, a by b, only there is a problem of the sign. There is a problem of the sign, nothing else, same thing. So now I can substitute the value of a and b and then integrate it, and I will get that big equations. That is the application of the partial fraction method. So let me just solve it by this method. I'll also do all these things. So I'll now use this a minus x plus b minus x dx and k. You can write 2 or simple k, no problem. So here now we know that the value of a and value of b minus a by b, and this is a minus b, same thing, so common. So if I write like that, 1 divided by a minus b, no problem. Then integrate whole part. So it is, you can write even directly on, also you can write, because it is minus, so I can write like that. plus dx. You can write, or simply you can write like that, and k dt, dx like that. Now just you remember, this is the first order reaction formula, dx 1 by x. You all know dx 1 by x. So such a big equation, with the help of partial fraction method, we will have a very simple equation. You all know that same thing, dx a minus x integration, very simple, dx b minus x integration. So right. So suppose, you know, like we can use that dx a minus x is school level integration, in almost school level. And suppose this is actually a minus x, you can use the u. You all know u. So differentiation with respect to time, a is a constant, so minus dx is equal to du. So if I substitute the value of this, is actually minus du and u integral. So natural log of u, natural log of u, natural log of L minus x. Therefore, in first order kinetics, generally you get minus log a minus x. So easiest formula. So I write like that. I am not giving any value 0 to x or 0 to t. No, I simply indefinite integral a minus b. Now if I just write it, so b is because minus, so natural log a minus x. Here this is plus, so if I just dx b minus x, so it will be b minus x is equal to k, dx is equal to x, so k and t. Last stage, last stage. Okay. Plus, of course, integration constant. See. So I can write like that, 1 a minus b natural log a minus x divided by b minus x, like that, is equal to plus. Now you know that just like your normal system, when t is equal to 0, so just imagine that nitroethane or ethyl acetate, when t is equal to 0, no question of sodium acetate or alcohol or whatever it is, no question of the product. So quite natural hai, quite natural is x is equal to 0, x is equal to 0, this part is also 0 because t is equal to 0. Or even you can do like that definite integral also, that is also possible. From 0 to x is also possible. So it is up to you that which method you can use directly from here also. 0 to x and 0 to t is also possible. Indefinite is also possible. Same thing. Directly you can, if you are a mathematics student, so you need not to solve all this system. Directly you can solve it 0 to x and 0 to t. But again, for some biology students and other thing, I am just using the simplest method. So it is like that, 1 a minus b natural log a by b because x is there. You just okay. 1 by b, natural log a by b is equal to c. Is equal to c. Substitute the value of c in this equation. Substitute the value of c, integration constant, or I you can write here. So 1 divided by 1 minus b natural log a minus x b minus x is equal to kt plus 1 divided by a minus b natural log a by b. So last stage, you have to determine the value of k, second order, or k2, all right. So last step, So if I just rearrange this equation, and it is again, you have seen it is a common, a minus b. So I can write like that. I am using very simple and stepwise method. Directly you can integrate it. Absolutely, if you are quite intelligent, so you need not to be solve all such type of things. Directly, now you can understand all these things. Common thing is common. So just if I write it as a minus, but again I am doing the simple method. 1 a minus b natural log a minus x b minus x is again learning process, minus natural log a by b is equal to kt. K I have to determine, or just I plus it. So plus it, what it will do? B A. So final equation 1 by B common natural log B A minus x A B minus x is equal to kt. Just what I am getting? 1 divided by 1 by b natural log b a minus x a b minus x is equal to k2. Now, but I want k2. So 1 by b so this one you can write it bold. So finally I need the k value, second order rate. So k is equal to 1 by t, you can write a minus b natural log b A minus X, A P minus X. Now if you just, again you convert it into, because before start this lecture I have given a simple numerical problem and then I derive this formula. Even you can write here K2, that is also not a problem. And if I just change it this log, so it will .303. So this is the final formula. K2 is equal to 2.303 T log A minus B, A minus B log this 10 B by A minus X, B minus X. Now just again I am going to the first part. First part, that we know the rate constant, that means we know the value of K2, we know the value of sodium hydroxide 0.005, you can consider it as A, absolutely no problem. You know the concentration of the nitroethane, but the question is that how long will it take to 90% nitroethane to react? That means you have to calculate the time required for completion of that 90%, that means almost whole completion of the reaction. So for that, if you understand this thing, so you can solve it. So how do you solve it? So I'm just not solving complete thing, but I'm just giving you the hints. So K2 we know, it is 39.1 approximately, is equal to 2.303 T red color. We have to determine time required for 90%. A minus B concentration is 005 minus 004, 0.005 minus 004, I think 0.001, .001 log B, we know that .004, A we know 005, but we do not know X, divided by A we know 005, B we know 004, minus x. So x, because 90%, so and 90 divided by 100, and concentration is I think 0.004. I think it is 0.0036 and 30. So you just, if you now you solve it, that means 0.005 divided by 0.036, it is I think 0.014. 0.005 minus 0.036, 36 and 50, so 0.014 multiplied by 0.004. Here 0.05, 0.004 and 36, 0.004, like that. So if you solve it, you will get around 3, or it is actually log of 2.8, around. So you have to calculate the t. So t is equal to 2.303 into log of 2.8, and here it is actually 39.1 into 0.001. It is approximately 30 or like that, 26.1 minute. So my objective is that you have already solved very simple system, but where there is concentration is similar, you have also seen that 1 by t x a minus x. So this is the beauty of the mathematics. This is actually x. So this is the beauty of the mathematics, that the same reaction A plus B, second order, but difference is that here A is equal to B. Same reaction, ethyl acetate, sodium hydroxide, 001, 001. You will get this type of formula. Same reaction where A is not equal to B. Same reaction, order of reaction, no change. But you see that just for a different concentration, complete different equation will be evolved, and for that we will depend on the mathematics, that is called the partial fraction method. So this is the two purpose will be solved. Number one, the application of partial fraction method for derivation of second order kinetics, where the concentration of both the reactants are different in one question. Second, suppose we give you some numerical problem like nitroethane or any types of numerical problem, but if you understand this system, so you can solve any complicated numerical problem. Thank you very much.